Alright, so no more nice stuff. We were able to solve exponential equations by making like bases, not the case in every single problem. For example, there is no number that you can raise to a power and get 5, raise to another power and get 21. So, like if you had 2 to the x equaled 16, you could have said, well, this is 2 to the x equals 2 to the 4th, and solve it like that by saying that then x has to equal 4, and you'd be done. Not the case with these guys, so here's how you're going to solve them. We need to undo this exponential, which means I need to take a logarithm of both sides. Specifically, I need to take a log base 5, because that is what the base is on this side. So log base 5 of 21. So when you do that, the log 5 and the 5 cancel out, and you're left with x equals log base 5 of 21. And honestly, you can leave it just like that unless you're looking for a decimal answer, and we'll talk about how to get that here in a moment. For this one, same thing. You're going to do log base 8 of both sides, log base 8, and what that does, cancel it out, and you have 3x plus 2 equals the log base 8 of 12. And to solve for x, just like you normally would do, subtract 2 and divide by 3. So log base 8 of 12, whatever that number is, you're going to subtract 2 and then divide by 3. And that's how you set up your answer. Now, if I bring in a calculator here to show actually how to put that in a calculator. So if you do just log of 21, for example, well, that's log base 10. The way that you do it with the log base 5, you would do log 21, then divide by log of the small number. So that's what this first guy ends up being, is like 1.8 something. And I think it asks normally to go to 3 decimal places. So in this case, 0.892 is what I should go, 0.892. Now for the second one, the way you'd have to do for log base 8 of 12, you do, again, log of the big number divided by log of the little number. We're taking that number, we're subtracting 2 from it, and then dividing the whole thing by 3. So there's what your answer approximately would be, is negative 0.622 for that second problem. Okay, so let's look at a couple other basic examples. We're not going to go through the decimal part of this, but it works the same way. We cannot do a log until we have everything by itself. So I'm going to subtract 2 from both sides first, and then you get 3 times 15 to the x equals 27. Divide both sides by 3. 15 to the x will equal 9. There's no number that you can raise to a power to get 9 and raise to a different power and get 15. So that means I need to do now a logarithm of both sides, log base 15 to both sides. So x will equal log base 15 of 9, and you're done. With this one, subtract the 6 first and get e to the 8x minus 1 will equal 9. And we need to do again a log of both sides. This is log base e. We call log base e the natural log. So I'm going to do natural log of both sides. So it leaves you with 8x minus 1 equals the ln of 9, which means x will equal ln of 9. I'm going to add 1 and then divide that by 8. And if you had that with a calculator, you do have an ln button that you can use instead of the log. Make that one even easier. So ln of 9 plus 1. And then that whole thing needs to be divided by 8 for that decimal. Okay. Here's 5 last ones for you to try. I would suggest pausing the video and seeing if you can get the right answer when you come back. So let's see how you did here. First problem, move the 3 first, and then take log base 4 both sides. And there's your answer as a result. Number 2, divide 10 first, because 3 is your only base. So then you have 3 to the negative x equals 100. Equals 100. What did I do there? That's silly. 400 divided by 10 is 40, last I checked, so that should be 40 for this part. So log base 3 of 40, and then divide the negative out to get your final answer there. In number 3, multiply by 4 first, subtract the 1, that gets your exponential by itself. Then you can take the ln, because it's e as your base, natural log of both sides, add 7 to finish the problem. Number 4, subtract the 14 first. And then this one, we take log of both sides. There is no base because it's assumed as log base 10, because we have the 10 fingers on our hand. And then this last one is one you don't even need to do work. Subtract 2 over, or subtract the 4 over, you get negative 2. An exponential can never equal a negative number, so no solution. If you try to do log base 7 of negative 2, if you try in your calculator to do the log of negative 2, it won't work, because it's a non-real answer. So that's the way you can confirm that with your problem. There you go, solving exponentials with logs.